we know you have to secrete water. We also know you secrete mucus. Tell me about mucus. Is it sticky? Huh? Yeah. Does it, under normal functioning conditions, does it stick to the lining of your digestive tract? Let's think, what would that mean? It means it's not moving. If it's too sticky, if it sticks too much to the lining of your digestive tract, it doesn't move. Remember that migrating motor complex? Now I'll ask the question. Does the mucus move?
Mm-hmm.
Yes. We want it to protect the lining, but we don't want it to stick to the lining, right? Because if it sticks to the lining, it's going to stay there old, nasty, gooey, yucky mucus. So we want it to protect the lining, but glide across the lining. All right, now this is going to be disgusting, but it's okay. I won't do it, but there are a lot of mucus in. What? Is there? Mm-hmm. Yes. And if I put that on something, it would stick. But if I put on a piece of glass, let's say, stick. But then if I put water on the piece of glass and then spit the loogie on the piece of glass, what's it going to do? Slide right off. All right. So perfect. So now you know this is a piece of cake. If you want the mucus to slide across, we want a layer of mucus, but we don't want it sticking. What must be in between the lining of the intestine and the mucus layer? Water. Right? Water's got to be there. So I want to secrete mucus, but underneath the mucus I want to secrete water. There is no way to actively transport water, which blows my mind because water is so important for us, but my cells have no way to pump it in, pump it out. So it can't be as simple as just pump water out because I don't have any little water pumps. I don't have any little squirters in there. Okay? But I do know this, that if I'm in osmotic equilibrium and I move ions, what has to go with it? Water has to follow it, right? Because it has to stay in osmotic equilibrium. So if I'm pumping ions out, I've just made myself be actually now in osmotic disequilibrium, so what's water got to do? Go with it. Right? So it's called solvent drag. Water follows ions. All right. Now, can I actively transport ions? Absolutely, right? We have proteins embedded in membranes that use ATP or something else to pump ions. And in this case, the ion that I'm going to use to pump is chloride ions. So I'm going to use chloride ions, and I'm going to pump chloride ions, and what's water going to do? Go with it. Water's going to go with it. So here's my lumen right here. And if I have a particular channel here, it's called a CFTR. I'll tell you what that means in just a second. And that CFTR channel is permeable to chloride ions. So if I have a source of chloride ions inside my cell, which I do, because I have chloride ion transporters here that bring them in. Now notice this is interesting. This one protein right here is bringing in both, what's that ion? Potassium, chloride, and sodium. So are the charges balanced here with everything it transports?
No. Oh, yeah.
Really?
Yeah.
Yeah, sure. 2 pluses, 2 minuses. So that's another thing that you got to keep in mind is that not only do we want to maintain chemical equilibrium, osmotic equilibrium, things like that, we don't want to mess with charge. We want to keep charges kind of the same. So that means if I'm pumping something that's a plus this way, I better take with it sometimes what? A negative. Or if I'm putting one plus thing out, I'm going to take a different plus thing from outside and pull it in. I want to keep charges constant. Okay? So that's all this is doing here, is keeping charges constant. So I bring in chloride ions. So these cells right here, lining the digestive tract, have a source of chloride ions. And because of that, these chloride ions are going to be in a high concentration here. they're going to be in a low concentration here, okay? Because I'm pumping them in here, keeping them in here, high concentration here, low concentration here. If I have a channel, they will just diffuse out. And when they go out, what has to go with it? Water. Okay. So as the chloride ions go, water is going to go with them. So not only am I putting a bunch of mucus out here, I'm secreting and having this barrier of water and chloride ions out there. You okay with that? So now, because I've got this water layer here, this mucus can slide on it. Now, if I didn't have this chloride ion channel, or this chloride ion channel didn't work as well as it should, tell me what that means about the mucus and the water. More or less water? Less water, stickier mucus. Now, that brings us to a condition called cystic fibrosis. Have you heard of that?
Yes.
Cystic fibrosis, the individuals that have cystic fibrosis have two main complicating issues. One of them are digestive, and the other is respiratory. And the reason that they have respiratory issues is because mucus is being secreted. Remember ciliated pseudostratified ET? It had goblet cells, right? Secreting mucus into the respiratory system to help us trap pathogens, dust, things like that. Well, if we want that mucus in the respiratory system to move and not congeal, we also have to have water underneath that as well, right? So if a person has cystic fibrosis, they're not going to have that water underneath.